Guys, really quickly. Sorry.
Hold on. All right, so we are going to be working on the heating curve of ice one, okay? You guys are not allowed to really touch anything. However, what I have done is I have it all set up here. Hopefully it'll actually let me show you. Come on. All right, where is it? This one. Here we are. Okay, so I have it set up here. All right, where I have over there is your temperature. I know it's backwards. I am sorry. There's nothing I can do. All right. What we're going to do is you guys are going to follow along, and I'm not going to tell you when to take the temperatures. So you need to take out whatever device you have a stopwatch on, and every 30 seconds, when I tell you to start, you are going to take down the temperature reading. Okay? All right, so right now, the lowest temperature we have is about a 0.4. Okay, so that should go on time 0. Okay, for the heating curve of ice. All right, we're going to try and get it down as close to 0 as possible. Okay, so, all right, I need you to start your timer. Every 30 seconds, you are going to take a temperature reading, okay, here, all right? The first one was about 0.3, okay? After that, guys, from every reading from now on, after the 0.3 degrees, you're gonna do it either to the 0.5 or 0.0. You're gonna round it to the nearest 0.5. So after 30 seconds, remember, you're timing this. After 30 seconds, the only thing I'm timing is the first 2 minutes. Well, I'm not telling you the 30 seconds. I'm just saying for the first 2 minutes, you're supposed to keep it off the hot plate, which is what I'm doing. So all I did was add a little bit of water in this just to speed up the melting process a little bit. Okay, but again, you are responsible for your 30 seconds. So I'm just literally doing the work. You guys are doing all the measuring on your own, and you're rounding it to the nearest 0.5, okay, or 0.0.
Miss Gonzalez, I can't see your screen anymore. It's just a letter.
Yeah, it keeps jumping. I don't know why. Yeah.
What's the current temperature?
0.2.
Would that run to 0 or 0.5?
Huh?
Would that run to 0 or 0.5?
0. Why is this not working? I don't know why that keeps happening.
What's the temp?
The temperature is 0.6. Oh my God, go away. Okay, there we go. Why this worked last period and not this period, I don't know. There we go.
How long are we supposed to be timing this?
Every 30 seconds.
What's the temp right now?
3.3, 2.0. Maybe we can use my restroom.
Wait, Mr. Gonzalez, so should I now just put
What grade now?
the temperature I have for my time? Or do I like start over?
Hold on, I don't know what this is, but it's really annoying me. 14.0. But I didn't change my screen. Because I can see it right here.
Wait, Mr. Gonzalez, so should I just start over now from the beginning?
No, just go by the
What's the time?
1.4 is what it says.
4.4?
1.4.
Wow. No, it's not working.
And don't forget, I'm also stirring it. Okay, so I am not allowing the thermometer to touch the sides or the bottom of the beaker. Okay, because otherwise what I'll do is I will end up taking the temperature of the beaker and not the temperature of the water ice mixture. Now it should be, if you think about it, what's the freezing/melting point of water?
In Celsius or Fahrenheit?
Celsius.
0.
0, right? So the temperature should technically hover around there because I have both the ice and water in here. Because remember, at this point, it should be melting the ice. So you're going to see that, right? You're going to see that as I am stirring this, okay, the temperature is going to stay pretty much consistent. Now you have to also take into consideration that melting point of water is specifically for pure water. Our water and our ice has other things in it than just pure hydrogen and oxygen. Okay, so that is actually going to change the melting and the boiling point of water slightly. Okay, so if you look at this now, right, we still have ice inside the beaker. You guys can all see that, right? And we still have water in the beaker. So we haven't completely melted the ice yet. So you don't expect to see a very large change yet. Okay. Now the whole point is you guys are going to take this data at the end and you're going to graph it based on your data, obviously. So you should see a pure heating curve like the one that we drew in class. So you should see it where it started out as a solid, goes to melting, which is what you were trying to figure out what temperature, right? You're going to find that plateau. Yeah, because you're all doing it from the same thing. So you should have the same, pretty much the same answers. But that's only if you're timing it exactly the same. And not everybody is.
Yeah, I'm really have to come to 3 Celsius, just have to write the number.
For now, yeah.
Yeah, that's just great. Is there a starting purpose at all?
No, it's not really. Stirring it doesn't really require a lot of wrist motion. It's not that big. It's not like it's a gigantic pot of sauce.
I remember last year the church, she gave us sugar and water things, and wanted to melt it, and then
Yeah, we have to basically like swish around like liquid in a beaker and like, we have to take turns because like how quickly our arms
because the
Okay, so we still have ice in the beaker. You can still hear it. Not a lot, but it's still in there. So now we pretty much have no ice and it's only liquid in here. So what we're gonna try and do is we want this to boil. And when I say boil, you want it to be a rolling boil. You don't want to just see little bubbles on it. Now, the melting process happened pretty quickly. And we know this to be true because that heat of fusion value for water is much smaller than that heat of vaporization value for water, right? HF is a lot smaller than HV, right? So this is going to take a lot of time. Right, because the water itself has to gain enough energy to overcome those intermolecular forces of attraction, right? You guys remember me talking about that?
Yes.
Awesome. Okay, so what temperature about should we be looking for this water to be fully boiling? 100 degrees Celsius, exactly. Because you're smart like that. And you had a really good teacher.
Yeah.
What can I tell you?
Yeah, explain to me why you want to take the midterm tomorrow.
Because he wants to get it over with.
I'm not hyped at all.
Yesterday's midterm was actually.
Because
No, part one was pretty okay, but it's part two that's got way harder stuff.
Yeah, we'll see how you guys do.
Hopefully there'll be extra credit.
There is no extra credit. I am not allowed to do the extra credit.
Only extra credit was science research, and I forgot to do that.
That was only for quarter one.
Yeah.
Hopefully there's people.
You guys are still taking temperatures every 30 seconds. Okay, and rounding it to either 0.5 or 0.0.
Oh, 0.5 or 0.0?
Mm-hmm.
Oh.
But if you're already writing, like if you put down 19.2, you can figure out later that it's really 19.0.
Yeah, this runs on the real temperature.
That's fine. Remember, when you go to do this write-up, the data table needs to be typed. Okay, the only thing that you don't have to type is going to be the calculations. Okay, and the graph. That is it. Everything else needs to be typed.
That's kind of a
We had a lot of math in it.
Which one?
The gravity on other
It
planets.
wasn't, I don't think it was that hard when I tried. It just took a really long time to do all the calculations.
You know, my definition of long time is hard. I have zero patience. Yep.
Okay, so we're still only at 28 degrees right now. We have another 70 plus to go.
My guess is that it's going to start accelerating at 11th grade.
Now, I'm also attempting to stir it to get the process moving along, because when you stir it, the molecules move more, right?
Just a little bit.
Just a little bit, right? In the process of melting the ice, when I stirred it, I was actually letting the water that was already there come in contact with more of the ice, which allowed the process to move faster. Yeah, because you're using it as your timer anyway, so. And again, I'm doing my best to not touch the thermometer to the beaker. The only reason I keep switching hands is because this is very hot.
Would that like break the glass if you held it up on
Mm-mm. It's just that it would take the temperature of the glass and not the true temperature of the water, which you know is going to be different because glass is going to have a much lower specific heat than, or it's going to have a different specific heat, I should say, than water.
Side connection, everything.
Yep.
Unfortunately, mostly that.
Well, sometimes. But yeah, so the big thing is too, guys, you notice how I'm not sitting down during this part, right? There's a main reason for that. It's because of your safety, okay? Now, there were times that I've seen where, don't forget I taught chem as well. So there have been times where I've seen that the students did nothing wrong, but the entire bottom of the beaker fell out. They went to, because it actually melted on a steam, so it was a perfect cut, and boiling water came flying down. Now, if they were all sitting, they wouldn't have been able to move away quick enough to actually escape the burning death of water, okay? No, thank God. Even the kid who was picking it up using the tongs, he was able to jump out of the way for that reason. But that's, again, why when you deal with labs, you never actually sit. When you guys go to chem next year, especially, which I know you're all doing, of course.
Wait, chem next year?
We're just gonna pretend that you're all going to chem next year. Okay? When you deal with a chem lab, especially, you never, ever, ever, ever sit. There's too many probabilities of you getting burned or stabbed or splashed or cut or something, and you never, ever, ever, ever sit. Like if you guys were able to actually do this lab and not have me demo it, you guys would not be sitting.
I'm just doing my jobs.
You guys did a lot of, did you guys do any of the bio labs at home last year?
Nope. Zero.
Oh.
She just posted work for us to do like worksheet total.
And that's why I did way better. I like those last couple quarters.
I like the totals because I definitely the total during school year and then during summer school Mr.
Baraka?
No.
Petrie?
Yes, Patrick. Mr. Patrick, he always gave us totals and I did them, so then got the answers.
Oh, Lord.
I had like a 9 on this class. Almost impossible to fail summer school. Almost, but something.
All right, so I don't know if you guys can see this, but let me move this closer real quick. There's little tiny bubbles starting to form at the bottom. There's the
76.5.
Okay, there's little itty bitty tiny bubbles starting to form. Okay, that means that the process of boiling hasn't started yet because you don't actually see it. All right, but those bubbles tell me that there's the start of that density change. Man, what's the matter?
Oh, no, that's remember if you could send me the ones that I posted.
No, you can just remember I'm recording this.
Oh.
So you could rewatch it.
All right, thank you.
That's why I'm doing it. Oh, there's a couple of bubbles that are actually starting to move up. You guys see it? Okay, that's actually that convection current. Can you guys see? It looks like wavy lines a little bit, right? There's the molecules that are moving.
straight to
See how there's little tiny bubbles that are starting to form.
18 minutes of max. That's crazy. Like, all you have to create is gone, just like sitting around, taking down numbers.
Mhm.
for good calls.
See, it's starting to bubble. That is not 100% boiling yet. You're looking for that rolling boil. Like you would not add pasta to this right now. Okay, if you added pasta to this, it would not be ready in the allotted time that it tells you on the side of the box.
My mom fills it with pasta before she shows up on it, so.
Okay.
Yeah, it's just.
Stir around, I guess.
Yeah, it depends on how people learn how to cook. I learned not to do
She
that.
does it against the wall to see if it sticks and if it sticks and stuff.
It's done. That's because it's starchy at that point.
She always gets pasta. I'm always tired of pasta.
All right, so you see it's really starting. Look at the temperature. Look what's actually happening. I kind of like the picture of it better than me looking at it itself. Look at the temperature, right? We're still not at that rolling boil yet, but we are boiling. You can start to see some of the steam coming off. I don't know if you guys can see that. See the steam?
Why do you get so moving?
Because I keep moving because I'm burning my hands. Okay, so now I would say this is a rolling boil. So you have to take 4 more temperatures. Now the way that you know that you have the boiling point or the melting point is if you have the same temperature 3 times or more in a row. So if you guys get the same temperature 3 times in a row, you've hit the boiling point. Okay, and I want you to take an additional 3 readings after that.
So if we get 100 more times in a row, we can stop.
Mm-hmm. Because we're not going to go until all this water evaporates, because that could take a very long time. And my fingers are burning.
Oh no. Has he moved?
No, it's okay. Thank you, though.
That's to be the same 3 times, right?
Right, but remember, you're rounding it to 0.0 or 0.5.
If I got it 3 times in a row, does that mean I can stop?
Take 2 more.
Okay.
Actually, take 3 more, I think I said.
Yeah.
So I said if you get the same thing 3 times in a row, take an additional 3.
Okay.
But what if it's different after the additional 3?
It won't be.
Okay.
Oh, and you let me know when you're done. Guys at home, how's it going?
It's good.
Good.
You guys got the same reading 3 times in a row at least?
I did.
Good.
I never knew boiling water could be so much different.
Watch the pot never boil.
Mhm.
So does the glass like below dragon at the bottom? No way.
Alright, I got the additional 3.
All right, so did everybody get 5 to 6 in a row that are exactly the same?
Yeah.
All right, because I'm burning my hands now. Okay, so now, while I let that sit there, okay, look how fast it's cooling down. All I did was move the thermometer to right there. All right, look how fast it cools down. Okay, so All right. So what next? Well, now that you have filled this out to the best of your ability, we did not reach to 2530. It's okay. You're just going to cross out the rest of them that are blank. Okay. Then what you are going to do, right? The time right now is 1:43. Okay. We started at what time, Owen? Do you know?
Started 22 and a half minutes ago.
22 and a half, was that after?
So that's,
So it's actually 20 and a half because 2 of those minutes that we didn't start heating it yet. So it'd be 120.
124, no, 123.
Let's say 122, 21. Let's say we started at 121. Okay. You're going to look at your data in here and figure out what time did the ice melt completely. Okay. And then, or the total amount of time it took for the ice to melt. Okay. So you're going to look for the temperatures where they're the same, where that plateau will be. So let's say your temperature was 1 degree. You're going to look for the ones that say 1 degree, 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 1 degree. And however long that took, you're going to put that here. Okay. The water boiling time, same thing. How long did it take to boil? Your selfie, okay, you're going to take with the beaker. All right, which is right there. And I'll put it back up in a minute for you guys who are here to take it. Okay, you are going to type the answers to these 5 questions, and you're going to support it using your data points. Okay, you're not just going to say, well, the answer is this. Well, why is the answer blue? Okay, you got to give me a reason why. The other thing you're going to do is you're going to take your data on this piece of graph paper that I have attached, okay, and you're going to create a graph. Okay, the graph should be temperature versus time. So temperature should be on the y-axis, time should be on the x-axis, both of which need units. So did we do it in seconds? Are you measuring it in minutes? How are you measuring it? Did we measure our temperature in degrees Celsius? Did we measure it in Kelvin? Did we measure it in degrees Fahrenheit? What did we do? Okay. With every single graph, you need a title. You need to label the axes with units. If there's more than one line, you need a key. You need to circle the points and you need to connect the points. I can't tell you how many of you lost points on the Tide Graphing Lab because you didn't follow those 5 things. Okay, for every graph you do, you need a title. You need the axes labeled with units. You need the points circled. Okay, if there's more than one line, you need a key. And what am I missing? Oh, you need to connect the points. Okay, that's what you're going to do for this lab specifically. All right, so really quick, here is the beaker that you can take your selfie with. I'm trying not to get anybody in the picture. That's the best I can do. Blur out the background, guys, take your picture.